one, this is just finding arc measures, and these are central angles because the point in the middle is smack dab in the middle. And then what I would do is just fill in everything first and then go back and look at this. So if I look, I have 53. Where the 53 is at, I have a right angle. So these two little slices of pizza right there and right there together are complementary, meaning they add to make 90. So if I take 180 and or not 180, if I take 90 and I minus 53, that makes 37 degrees right here. So these together make a right angle that makes 90. I can find the angle that's next to 37, this big piece, because half of a circle makes 180. So if you have a diameter that cuts through the circle, through the center, that's 180 degrees in total. So if I take 37 and I minus it from 180, I can find 143 for this big portion. And I can use that same method for the other side. So the diameter is on the other side as well. So 180. I have two, so I'm going to subtract 79 and 53 from 180. So this is 48 degrees. So now I can just go back and fill it in. So from C to D is 37. A to B is 48. E to D is the big piece, which is 143 degrees. Number two, this is still central angles because it's from the center. So from the center, that means that this is a vertical angle, this is a vertical angle. They are congruent to each other, which means the arcs are also congruent to each other. So if you have congruent pieces, you can just set them equal to each other. So I'm going to do 13x plus 13 equals 15x minus 7. So I'm going to get rid of the minus sign by adding. Numbers go with numbers. So 13x plus 10 equals 15x. So I'm going to minus 13 both sides. Minus 13. So 10 equals 2x. So x is 5. I do need to find the measure of EF. So if I look back, EF is this portion right here. So if I plug it into one of these, I'll plug it into this one just because 13 times 5 plus 3. This piece is 68. I need the arc next to it. So once again, if I cover it up, I have a diameter. So half of a circle is 180. So if I minus that from 180, I get 112 as my answer. So EF is 112 degrees. For number 3, oops, this is an inscribed angle. So inscribed angles are not the same as central angles because it does not go through the center. So you can do one of two things. You can cut the arc in half and set it equal to the angle, or you can take the angle and multiply by 2 and equal to the arc. So I'm going to show you both. I'm not going to do both, but I'll show you both equations. So I could take 94, cut it in half, and equal it to 9x minus 25. Or I could do the opposite. So I can multiply this by 2 and equal it to the arc. So either way, you're setting them equal to each other. I'm going to solve this one just because there's more space. So 94 divided by 2 is 47. 47 equals 9x minus 25. Add 25. $72 equals 9x divided by 9. X equals 8. This one's just solve for x, so I don't have to plug it back in. If you solve this one using distributive property, you would still get 8 as your answer. 4 is a party hat. You have two tangent lines. So it says DE and EF are tangent, okay? So it's a party hat. To circle G, we have to find EF. So party hats, what we know about two tangent lines is that they are congruent to each other, okay? So we're going to set them equal to each other. I'm going to move the 19 because it's got a minus sign. Four x plus 23 plus 19. Oops, 23 plus 19 is 42. Minus 4x. 42 equals 6x. Divided by 6, you get 7. Because I need to find EF, I'm going to plug it back in. It technically doesn't matter which one you plug it into because they're congruent. 10 times 7 is 70. 70 minus 19 gets me 51. So this is 51. So EF is 51. These problems are kind of close to each other, but the next one, number 5, is this. So these are not central angles. This was a central angle. Goes through the center. This is not a central angle. So this is where all these weird formulas come in on your formula sheet for chapter 10, which I think this is a little overwhelming to look at, but it's okay. What we talked about on this, yes. Okay. So for this one, it's intersecting, but it's not through the center. We are adding the arcs. We're dividing by 2, and it's going to make this angle right here and right here. So I'm going to take my arcs. I'm going to add them. And then I'm dividing by 2. So 92 plus 140 divided by 2 makes 116. That means 116 can go here and 116 can go here because vertical angles are congruent. So 116 degrees. Using the same method, it's the same type of problem. It's just equations. So we're going to take the arcs. We're going to add them. So we're adding these. I'm dividing the arcs by 2, and then it's equal to the angle in the center. So normally I'm trying to find the angle. The angle is 11x minus 9. So if I combine like terms, 9 and 15 come together, make 24x. Negative 3 minus 39 is negative 42. So at this point, you can do one of two things. You can just literally divide these by 2, or you can multiply both sides of the equation by 2. If you multiply by 2, they cross out, or I can just divide. So I'm going to just divide. 24 divided by 2 is 12x. 42 divided by 2 is 21. And now I have like a normal math problem. I'm going to add 21. Be careful because this 9 is negative and you're adding 21. So that makes 12 on that side. If I subtract 11x, I get 1x. So I get x equals 12. I still need to find AED. So AED is this side, which is a vertical angle to this. So I'm just going to plug it into the angle. So I'm going to do 11 times 12 minus 9, which is 123 degrees. For the next one, this is also on your formula sheet. This is involving, where is it? These type, no, where's it? Oh, it's over here. These types. This is all the same formula for angles. You're doing big arc minus small arc, divide by 2, and that equals the angle on the outside of the shape. So big arc. This is my small arc. My angle is what I'm trying to find. So I'm doing big minus small, divide by 2. So 125 minus 51 dividing by 2. And makes 37 degrees. Using segment length formulas. So segment lengths, this is these three. This one you crisscross, you multiply the same on the line. These two are the same. It's outside multiplied by the distance added together. Outside multiplied by the distance added together. So you are looking at the numbers that are on the same line as each other. So 14 is on the same line as 11 or x plus 11. So these two are going to go together. So I'm doing 14 times x plus 11. On the other line, you have 16 and 2x minus 5. So I'm doing 16 times 2x minus 5. And then I'm going to distribute into the parentheses. So 14 times x is 14x. 14 times 11 is 154. 16 times 2 is 32. 16 times 5 is 80. And then I'm going to get rid of the minus sign because it just makes my life easier. So I'm going to add 80 because that's opposite. Numbers go with numbers. 14x plus 234 equals 32x. Minus 14 to both sides. Two 34 equals 18x. Divide by 234 divided by 18. So x is 13. Number 8, still segment length. I'm taking something on the outside, so like 7. And I'm multiplying by the line added together. 7 plus x. On the other side, I have 6 on the outside. And I'm multiplying by the line added together. 6 plus 15. So I can distribute this. That makes 49. 7x. You could distribute over here. I'm just going to combine these. 6 plus 15 is 21. So I'm doing 6 times 21. So this is 126 over there. Now I can minus 49 and then divide. So x equals 11. Okay, 9 is the same type of problem. We're doing outside multiplied by the entire length of the line. So if I choose 12, 12 is on the outside. I'm doing 12 times the line added together, 12 plus x. Then I'm doing outside, which is 18 times, and usually it's the whole line added together, but there's nothing to add. So it's like 18 plus 0. Okay, so I'm just multiplying by 18. Distribute 144, 12x. 18 times 18 is 324. Minus 144 from both sides. So x is 15. Okay, last type, I'm solving for CD, so I need to find the length. So basically, whatever I find for x, I have to plug it back in, so it has an extra step. So taking outside, which is 9, multiplying by the length of the line added together. So 9 plus 2x minus 7. The outside, which is 7 times 7 plus 11. If I combine like terms in the parentheses, it'll be easier. So I have 9 times 2x plus 9 minus 7 is 2 Over here, 7 plus 11 is 18. 18 times 7 is 126. So I can distribute and set it equal to 126. So distribute 18x plus 18. Now I can minus 18. And then divide by 18. So x is 6. And then I'm going to plug it back in to find CD. CD is just this little portion right here. So I'm doing 2 times 6 minus 7. So 5. The last two are graphing circles. You just need to determine the radius in the center. So remember that your formula is x minus h squared plus y minus k squared equals r squared. So it's always opposite of the brackets. So my center is, instead of +4 or instead of +4, it's -4 because it's opposite. This is -2, so it's +2. And then the radius, normally this is r squared. R squared gets me 16. So I'm undoing the square. So I'm taking the square root of 16. So my radius is 4. Same thing for the next one. This one has no number. So that's going to be 0. This is opposite of the bracket. So instead of plus, it's negative. And then I have to take the square root of 49. So my center is 0, -1. Radius is 7.